Morning, everyone.
Morning.
Awesome. I hope everybody's as excited as you are. Perfect. So how's the conference going on? You excited for the announcements?
Yep.
Perfect. So thank you so much for sort of waking up early in the morning and coming for the caching talk. I hope you're sort of take this information and cache it in your brains, and then you love cache and you keep using cache. This is what the talk is titled, like how to build performance applications using Microsoft Azure Cache. And in particular, I'm going to be talking about the new cache offering that we have in terms of sort of Redis cache. And that's going to be what we'll cover in this next hour. My name is Pranav Rastogi, and I'm a program manager. So here's my contact email address. There's also my Twitter account. If you guys want to get in touch with me about caching, and if you have any questions on best practices, architectural guidance, hey, this thing sucks, can you please improve it? I would love to hear that feedback. So, let's do a sort of round of introductions and set the agenda for the talk for the next sort of 75 minutes that we have. This is me. In my work time, I sort of manage features in ASP.NET, so around the membership system, sort of getting started with file new. And I also own the Azure cache offering, so the Redis cache itself. I have co-authored a book on ASP.NET 4.5. And in my spare time, I like to go hiking quite a lot. This is a picture of me sort of climbing up Mount Adams in Washington. And the reason this picture was fairly interesting to me was I took this picture and I uploaded it to Google Drive. Google scanned the image and decided there was snow on the ground, but there was no snow falling. And they sort of sprinkled snowflakes all over the picture as well. So I sort of find it hilarious that you upload pictures and somebody is scanning your pictures, but oh well, that's the story of the day. So it's a little bit about me, in terms of what do I do at Microsoft. In terms of the agenda for today, we'll just look at a basic 101 caching pattern as to why you need cache before we even go into details of Redis. Then we'll look at sort of why Redis, why did we decide to pick Redis and offer Redis as a caching service in Azure? What are some of the key benefits that you would get by using Redis in your applications? We'll also look at the Azure Redis offering. So this will cover value adds that we add in Azure by sort of providing Redis as a PaaS offering for customers. And lastly, we'll look at this sort of FAQ section. And this is, you can think about it as sort of gotchas, best practices, recommendations. But these are sort of list of questions that at least we keep getting from the service side from lots of customers. And my hope is that, in these questions, you can sort of see common patterns and sort of common pitfalls that you might have while choosing one option versus the other. So we'll sort of look at these questions as well. If you have any questions that you want to ask, just raise your hand, ask the question, and I'll repeat the question for folks who are going to listen online. We can make it a fairly interactive session. Also, the talk is titled as a sort of level 200. So I'm going to be covering best practices. I'm going to be showing code pieces as well, wherever applicable. And if something doesn't make sense, just raise your hand and I'll try to explain it as much as possible. So that's the agenda for today. Like, any questions on that or things that you would like to see during the talk? Okay. I'll ask that question again halfway through it, and we can change the course as well. How many folks have used Redis in the audience? Okay. So good. So if we keep it at level 200, that works, right, for a lot of people then? Because there'll be an introduction to Redis, best practices, and how do I use Redis, so we're getting started. Perfect. Do people use caching layer in their applications today? Oh, not so many. Oh, perfect. All right. So this is what sort of a typical application looks like. I have my web front end. This could be a web app or a worker role, cloud service, or a client. which usually talks to a backend data store. In this case, it could be SQL or table storage, document DB, NoSQL, any persistent store. So a web app talks to a database, gets the data, and displays the data in a page or a form or anything. So that's how applications work. Typically, these applications are slow because then you have to have the network hop of talking to a SQL server, which could be slow. You have to run queries, which could be slow as well. And then so your app becomes slow. A level of caching that you can introduce in your apps is sort of called a local caching, where if you have sort of commonly used data that you want to display to the user, so for example, the last 5 tweets, if you have a Twitter application, then you can cache that data in memory with the application. So you can think of that just a key value dictionary that you're storing in your in-memory as part of your website. And the reason it improves performance is because accessing data from an in-memory store is much faster than going over the network and accessing it from a persistent store. So this will increase performance of your application. All this works well if you have a single instance. If you're building a cloud app, which is a distributed app by nature of being in the cloud, then in-memory caching fails, because as soon as you start to scale out your worker nodes, your web apps, in-memory cache doesn't scale because it's just tied to one node itself. So now you have to introduce a distributed caching layer in your application, and that's where the Azure offering comes in the picture. It is a distributed in-memory cache. And so what that looks like is then I have this caching service, which now sits between my web workload and my persistent store, and my web workload can sort of get the data from the distributed in-memory cache and sort of increase the performance of your site. So that's a very typical sort of a caching introduction in Azure. Where Redis sort of adds value from a caching perspective over other caching solutions is it provides high throughput. And I'll show you numbers towards the end of my talk. It provides, you can do about 100,000 get operations per second. And it has consistent low latency. And I'll sort of stress on the word consistent low latency. So lots of caching solutions have low latency, but latency varies depending on your workload, what time of the day or the month you are in. But Redis sort of has this consistent low latency. And these are numbers that we've got from our sort of performance benchmarks. Is for the 50th percentile, you can retrieve data in under 3 milliseconds. For the 99th percentile, it's under 10 milliseconds. So worst case, you have 10 milliseconds that you take to get data from a cache and display it on your web workload. And in an Azure world, all that makes sense if you're in the same geographical region, simply because cache needs to sit very close to your web workload. If you have a caching layer which is in a different region than your web workload, then you have to make a network hop to go to the different region and come back. So by the very nature that you're going to do a network hop, it's going to increase your latency, and it's going to defeat the purpose of having a cache. So make sure that your cache and client are in the same region. That's the number one sort of question that we get in terms of, why do I have high latency in my applications? It's because the client and the server are not in the same region. So I'll show you a very quick demo around caching. And so this is a site where I've so let me duplicate. I'm presenting from my machine, so each time I end the presentation, it switches to extended mode. So this is an application which I have built. It's storing customer information. And I have about 1 million rows that I'm storing in table storage. I'm also storing the same data in a Redis cache. And I'm just going to do a query on the customer name. And I'm going to query both the cache and table storage. And so it's looking up the cache information, finding the customer name. It's going to the table storage backend. Table storage, normally indexing happens on a primary key and a secondary key. So operations around finding me the customer name where name contains blah is expensive. And so using a Redis cache layer sort of increases the performance of a very sort of typical scenario like this. So you see, for Redis, it took 9 milliseconds. For table storage, it took about 22,000 milliseconds. So there's an order of magnitude of about 300 at least. So that's the benefit of just introducing a caching layer in your application.
What's the key is the name?
So key is the customer name, yes. And I'll show you different ways you can start taking advantage of Redis. Yes?
How is it different from the SQL in-memory SQL database?
So
if you use Redis versus SQL in memory?
In-memory is fine, but if you start scaling out, then in-memory doesn't scale. So that's why you need a distributed caching layer in your application. So let's now look at some of the features in Redis. And so a very quick definition of Redis is sort of twofolds. If you go to the redis.io homepage, it describes Redis as an open source advanced key value store. And the value add of Redis is it provides you with this rich data structures on the server side. So if you have a gaming application and you want to store the top 5 gamers, it has data structure which can store the top 5 gamers in terms of sorted sets or list or hash sets. So you can do these in-memory computations on the server, which is way more efficient than getting a data from a persistent store, bringing it in memory on the client side, and doing some computations on the client side. So that's the benefit of Redis. The second way to think about Redis is with the programming model it exposes and the feature it exposes, it kind of sits at the conceptual level, a layer which is very close to a caching layer. It has key value pairs, and very close to a database which has all these data structures that you can use on the server side to do computations. So that's a conceptual way of thinking about Redis. The reason we chose Redis, is Redis is a very popular sort of caching / data structure server. It's proven at scale. It's used by Twitter, GitHub, Stack Overflow, Craigslist. There's a knowledgeable community of experts around. There's a rich ecosystem of clients. So if you have .NET apps, PHP, Java, Python, Go, any client, you can use these open source clients and talk to a Redis endpoint, and the same with Azure as well. They're very easy to hire for. There are people who are experts in Redis right now. And this slide sort of talks to you about some of the features that Redis exposes, which makes it much more palatable than other sort of true caching solutions. So key expirations is there. You can have key evictions. You have atomic operations on these data sets. You have transactions. You have pipelining, which you can batch multiple operations and execute them over a single TCP connection. You have Lua scripting. You have pub/sub patterns, which means that Redis can be treated as a messaging system. It's not reliable, but it's extremely fast. So if you're building, again, gaming applications where you care about throughput, Redis pub/sub system is the perfect way to go. And if you're building SignalR applications and you want to scale out SignalR, you can use Redis as a backplane to scale out SignalR as well. And that uses the pub/sub feature of Redis. There are different clients in sort of multiple languages that you can use. There are databases, which is a logical grouping of keys into one database. It's just a logical grouping. There's nothing special about it. And then we have sort of replication. We have persistence. Persistence can sort of mean two things, where every write to the cache is persisted, or you can have a snapshot that backs up Redis every night or something around it. There's also clustering, which recently got introduced in Redis 3.0. I think it RTM'd a few weeks back. And clustering introduces this concept of server-side sharding, so where you can dynamically add or remove nodes from a cluster. And so that's in Redis as well in 3.0. So let's look at a demo which sort of highlights these features of Redis. So I'm going to go to the same app, and I'm now going to go to the products page. And so here again, I have a million rows of products, and products have categories. And I can sort of now start to use some of the features of Redis. So for example, I can say, give me products which belong in category apparel, and give me the top 5 products. And I can do this query both on the table storage and on cache as well. So again, the top 5 query is running on the Redis server. It's not running on my client, on my web application. So here's sort of the numbers, again, it's an order of maybe 70. So that's the benefit of having Redis and using the data structures of Redis is in-memory computations around these data structures is extremely fast and happens on the server side rather than sort of happening on the client side. You can also do queries around range. So give me all products which have price between 30,000 and 31,000. Again, it uses a different data set and does a computation of range, and it happens on the server side as well. And so we'll get the result. These numbers, 90 milliseconds for Redis and 500 milliseconds for directly talking to table storage. So when you structure the applications, these are the things I want you to think about in terms of how you can take advantage of Redis features. Right. So let's look at what do we offer in Azure in terms of Redis. And after that, we'll start looking at a lot more sort of hands-on demos around these features. So the Azure Redis offering is primarily a PaaS offering. We effectively take Redis and we host it on a cloud service, on a VM, and we give you an endpoint that you can talk to Redis, and that's pretty much our offering. That means that any feature that is there in Redis or any tools that you can use in Redis, for example, Redis CLI to monitor Redis, you can use it with the Azure offering. There's nothing special about the Azure offering. It's literally like a Windows port of the Linux implementation and hosted in Azure. So you can use any clients from redis.io, from the community, and it'll work with the Azure offering. It's a dedicated service. That means for each cache you create, you get your own virtual machine that you talk to. It's not a shared service. It's not a multi-tenant service. So you own basically the virtual machine and where the cache is deployed. You have different sizes where you can pick the cache from, ranging from 256 to 53. It's available in all regions. We are working to onboard Redis in China and the government cloud. We do support SSL, which is not something that comes to native. It's an Azure-only offering, so you can encrypt the data, get transferred to Redis. And Redis offering comes in two SKUs. There's a basic SKU, and then there's a standard SKU. Basic SKU effectively gives you one node, and you talk to the node. If the node goes down, then your cache goes down. So there is no availability guarantee with the basic node. In the standard SKU, we give you two nodes, and the cache service infrastructure will handle the master-slave replication or the failover from master to slave. And in your client code, you don't have to worry about this entire process of how does this replication happen and how does high availability happen. And standard SKU is a SKU where we offer you a 99.9 SLA on the availability of the cache. And so that's a SKU that we recommend customers if you want to go into production and you care about the availability of the cache. We also support RBAC, so you can have sort of role-based access control on who has access to provisioning the cache, managing the cache, and sort of any operations around it. You can provision cache using the Azure portal, or you can use PowerShell commandlets, or you can use Azure Resource Manager templates, or you can use the Azure Management Libraries, which is an SDK, C# SDK. There is monitoring and diagnostic support. So this is around, we have lots of perf counters on how busy your CPU is, how much memory consumption do you have, how many hits or misses do you have, get sets. So all these perf counters that we have. There are alerts you can set up on all these perf counters. So if you have a lot of keys that are getting evicted, you can get notified, and you can do some operation on that. We also support ASP.NET. So we've written providers for ASP.NET session and output cache that you can use to basically store the information in Redis. And we also have a memcache protocol shim. So if you have, for example, applications that you're using memcache as a shim, so for example, WordPress, then you can use the shim in Azure Web Apps, which will talk to a Redis backend, and then you can scale your WordPress application using the Azure Cache offering as well. So that's kind of the high-level overview of what we have in Azure. So I'm going to start showing you some demos around this Azure offering and the various Redis features that we have seen. Before we go that, so this is the Redis homepage, redis.io, and this is the landing page for Redis. You can look at all of the features over here, so transactions, pub/sub. You can look at all of the commands that are supported in Redis, and then you can run the same commands with the Azure offering as well. So let's go to the Azure portal. So to create a cache, you can say new data and storage, and then you can say Redis cache. And then you can enter your DNS name. So this is basically your cache name. You can pick a SKU. So you can pick between standard or basic, and then you can pick what size of the cache do you want to create. You can pick a resource group. So resource group are containers that help you manage lots of Azure resources. So you can have a resource group which can contain your web workload, which is your web app, your backend persistent store, and cache. And you can create the resource group as a single unit, and you can delete the resource group as a single unit. So that's the benefit of using resource groups. Oops. Then you can have your subscription, and then you can have your location. And location is something that we would recommend should be the same as what your client's location is, so that you get the benefit of having both the client and the cache in the same region. And you can say create. So behind the scenes, we provision a VM for you, and we deploy the Redis bits. We deploy our infrastructure, and so this takes about between 5 to 10 minutes. So in the interest of this demo, I'm going to use a cache that I had already provisioned. So I'm going to say browse and use this particular cache. So once you provision the cache, this is how it's going to look like. So you have your resource group, you have your subscription, location, this is your host name, what ports do you have, what keys. So let's use it in a .NET application. So I have this sort of Hello World console application. I've installed a .NET client. In this case, I've installed Stack Exchange Redis. And in my program CS, I have this sort of getting started method where I'm creating a connection to my Redis endpoint. So this is basically I'm using Stack Exchange Redis to create a Stack Exchange Redis connection multiplexer, and then I'm going to use it to talk to Redis. So here's what the interesting parts are. So this is my cache endpoint, my host name. I'm saying SSL equals true. So by default, we set SSL when you create a cache. And then this is the password that I can get from my keys over here. So same as using storage, you have a primary key and a secondary key, and you can keep rotating the keys as a best practice. So I create my connection. I create an instance of a connection multiplexer, and then in my application, I get a database, and I'm showing you a pattern where I get the value from the cache. If I don't have the value, then I get it from a persistent store. Then I store the value in the cache, and I retrieve the value from the cache. So in this case, I'm just storing basic strings, and there's sort of a compatibility between the .NET strings and the Redis strings. Eventually, it just utilized as binary data. And so if I run my application, you will see that this value retrieved comes from the cache itself. So that's just a very basic 101 on how do you get started with the cache. keep in mind on how I created this connection. I'm going to come back to it later when we talk about FAQs. The reason I sort of created this lazy connection is we want to encourage you to use a single connection for your entire app, because what we've seen historically, there have been bugs with Stack Exchange where if you knew up a connection multiplexer in different parts of your site, that accounts for a new connection to Redis. And after a certain point, the number of connections to a Redis server increases. And as the number of connections increase, it takes more time for Redis to process requests, and then your latencies are going to go up. You might see sort of timeout exceptions. As a best practice, stick to using a single instance of a connection multiplexer for your entire app. Right. So let's start looking at the various data structures that are interesting in Redis and sort of why they're interesting as well. So we look at strings. So again, I have the same, I'm creating the same connection multiplexer the same way I did for my getting started. I'm doing a set for a string, and I'm doing a get value. Here I'm storing objects in cache. And to store objects in cache, you need to serialize and deserialize. I'm using JSON.NET, but you can use your own serializer if whatever one works for you. And I'm also setting the expiration values for the keys. So in this example, I'm saying this key is going to expire in 1 second. And in my demo, I'm basically sleeping for 2 seconds. So when I get the value, there won't be any value in this particular key. So if I run my app, the current value is 1. It's sleeping for 2 seconds. And the expired key, there's no value because the key is already expired. So there's no value in it. So that's how do you go from strings to storing objects, which is a very commonly asked operation in cache. So the next thing is around sort of these general concepts in Redis. So there's pipelining, which is I can run multiple operations, and Stack Exchange has an async await pattern, so you can await on the results of each one of them and let them execute them in parallel. There's support for atomic operations. So in this case, I'm setting this value of for i3 to be 99. I call string increment, which is an atomic operation, which increments the value of i3 to 100. There's another atomic operation called string get set, which gets the value and then sets the value to 0. So in this operation, I'm getting the value, which is 100, and I'm setting it to 0. So if I get the value, it'll be 100, and if I sort of get the value again, it's going to be 0. So that's how you can do atomic operations in Redis. There's also mset and mget commands, which is basically multiple gets and multiple set within a single operation. So these commands are useful if you want to execute a series of get calls in a single connection. And so here's how you can do that as well. So you have your key value pair where you have your keys and your values, and you can do a string set, which is again setting the strings, but you're passing this Redis key value pair, so you're doing an mset call internally as well. And then you can get these values the same way. There's transaction. So I can execute these two commands. So this is increment string. So the default value of a key is 0. So when I increment it, it's going to become 1. String decrement is going to subtract it by -1. So it's going to be -1. And I can execute this transaction. And if both these, if this transaction is successful, then I can check the result. And I can display the result of the two transactions. So if I run my application, you can see that the old value was 99, the new was 100. I did a get set, which gave me 100, and also changed the value to 0. So that's why I get 0. Mget, I just set the 3 keys to value 1, 2, and 3. And in transactions, I basically incremented a value and I decremented a value. So that's transactions. And so these semantics are very sort of tightly coupled with Stack Exchange Redis, but depending on what clients you are using, you can perform the same operations in whatever clients you have. Let's look at tags. So tags are useful if you have scenarios. Let's say you have a blogging application which has lots of blog posts, and blog posts can have categories inside them. And so you want to run queries around, for this blog post, give me all the categories for the blog post. For this category, give me all the blog posts that belong to category A. Find me between blog posts 2 and 3, give me the common categories between the two blog posts. So if you want to run these kind of queries, you can use Redis tagging. And remember, all these queries happen on the server, and you can use the Redis data sets for it. So I have a class in my application called blog post, which has an ID, title, and a collection of tags. And I'm randomly setting up posts with different tags. But the key thing I'm doing over here is I'm defining these keys called blog post and 1, blog post 2, blog post 3, and I'm assigning tags to the blog post. And I'm doing a set add, so I'm using a Redis data set called sets. And I'm doing the inverse as well, where I'm defining keys called tag colon, where I'm associating blog posts with tags, so I can do the reverse lookup as well. And so let's say I wanted to see all categories for blog post 1, then I can do cache.setMembers and give me all the tags for post 1. If I want to find what are the common categories between post 1 and 2, then I can do a set operation intersect. I can also do a difference. I can do a union, so depending on what queries I want to run. And lastly, if I want to find what blog posts belong to category IoT, then I can just query on this key tag colon. So this is a very easy way. So I'm going to run this app. It's a very easy way to start tagging and doing these operations on the server side. And it's very fast versus getting the data from persistent store and doing it on the client side as well. So, show me all the categories for post 1, show the tags common in post 1 and 2, and then the last one was give me all the posts that have category IoT. So you can get these results fairly fast in Redis. Redis lists is another data set. And lists are basically linked list. And if you want to sort of have a query where you want to display the last 5 tweets or give me the timeline of my Twitter feed, then you can pretty much store it as a linked list. And so that's the representation of this data structure in Redis. It's extremely fast because as the list grows, like if you have 1 million keys, the insert operation takes O1, and the last 5 operations take O1 as well because you're just getting the last 5. So that's the beauty of this data structure. So again, I have the same blog post example. I am marking the last 5 posts as read. So I'm using left push and linked list. You can add from left or right. And then I'm doing a range where I'm getting the last 5 posts that were read. I can also do a list trim, which means that if I only want to display the last 5, I can trim the linked list to be only last 5, so that this linked list never grows beyond the 5 limit, and it's much more faster again. So if I run this app, show me the last 5 posts, basically. So that's an example of how would you use this list data structure as well. We have sorted sets. And sorted sets is what we saw in the earlier demo of products where I had categories and I was doing queries on give me the top 10 results or give me a range of results. And these are very useful if you're building sort of leaderboard scenarios where you want to have give me the top 5 gamers of my application or give me all the gamers who have a score between 10 and 20. So you associate a score with your value. So I'm using the same blog post example, and I'm using sorted sets as the data structure, and I'm adding a score to each value, and score is just a random number that I have in my application. So I can get give me the sorted list. I can sort the list in descending order, or I can also do a range between 3,000 and 8,000. And so if I run my application and I have 10 blog posts, I get the ascending order, then I get descending order, and I get the range of values between 3,000 and 8,000. So that's how easy is it to use the different data structures from Redis and sort of start using them in your applications. We're going to come back to connection options in a bit. So I'm going to show you how you can use Redis as a backplane as well in your applications. So if you guys have laptops or phones and stuff, if you can browse to this URL, it's Pranav Redis signalar.azurewebsites.net. This is a web app which is using Signalar. It's using Redis cache as a backplane to scale out. Has everybody got it? All right. So now you can hit this buttons on the left, and then you can start throwing fireworks. So you can change colors. Right. So it's a Signalar hub that's connected. It's scaling out over a Redis backplane. It's extremely fast. If you had like millions of users on this site, this would scale very well. Oh, wow. You can have trails as well. All right. So to use this, oh man, you guys are, I can share the source code of this demo. Hey, these fireworks are much better than the fireworks on the New Year's, actually. Did you guess what city is this? Oh, so nice of you. I was going to say Chicago. All right, you guys done? I'm sure in the perf counters, and we look at the number of get calls, it's got a spike. All right. All right. I don't know who did that. I should have a logger just to keep track of which one did you click. Boom. I wish I had sound effects for this one. Oh, that was cool. Man, 25 people are still active. Uh-oh, 5. All right, last strike. Should I move on? Yes. All right. So, to add Signalar as sort of add Redis as a backplane, this is an application that uses Signalar. All I had to do was I had to configure Signalar to use the Redis backplane. So I downloaded the Signalar Redis package, and I have set the endpoints, which is my cache endpoints, basically. So here's my cache name, and here's my cache key, and I have set the port number to be 6375. So and I've described a channel. So this is the channel where Signalar publishes all the messages, and when you start scaling out your applications, all the subscribers listen to this channel. And so behind the scenes, it's using the Redis PubSub feature, effectively. So that's all you have to do to use Redis as a backplane for Signalar and start leveraging the PubSub features in Redis itself. We also have session and output caching providers. These are 2 NuGet packages that you can download, which is these following ones. They bring in a new dependency called stack exchange redis.strongname. The reason we have a strong name stack exchange is because the Microsoft packages are signed. So we had to have a signed strong name package for stack exchange as well. And then in your web config, You can configure your cache providers to, again, just use the Redis endpoints, the access keys, and same for session. And then in my application code, when the page loads up, I'm just storing the current date time in session. And on my page, I am just displaying it, the session variable. And I'm also setting output cache I'm enabling output caching of the page as well. So if I just view this page up, and if the current time is 11:25, if I refresh, then it's just output cache. So this is basically what it takes to set up ASP.NET Output and session providers for Redis. All right. So far I've shown you a .NET story. I'm going to show you a non-.NET story as well. And so this is an application that I've written using Java. It was quite an ordeal to understand Java, but no, just joking. So this is a simple class I have. I'm using Redis, which is another client for Redis on Java. I'm connecting to my cache endpoints again, and I'm using port 6379, which is the non-SSL port. So remember that the SSL offering is only in Azure and not all the clients support it. So for those who don't, then you have to turn on the non-SSL port in the Azure portal and then use it to connect to the Redis offering. And I'll just show you how to do that as well. So if I go to my ports, you would see that allow access only via SSL is turned off. So I have two ports that I can use, 6379, which is non-SSL, and 6380, which is the SSL port. Right. So I'm going to change to say hello Ignite from Java. Save it. Go back to my console. Compile my Java application. And then run it. So I'm adding the keys 5 times. So here's, you would see the result as well. So that's Java. There is another example that we have. We have this client called Retwist. So Retwist is a Twitter clone that was used as a sort of a flagship sample on Redis.io on how to use Redis in Twitter. And Corey Fowler has ported the sample to sort of use the Azure Redis Cache offering. This is the GitHub page. I have links in my resources slide. And it has a little nice deploy to Azure button, which you click on it, it will ask you what's your Redis cache name, what's your website name, and it will provision a web app and a Redis cache for you in Azure. So I've already gone ahead and done that. And I can come over here and I can create a new account. So Ignite12, specify a password. And then I can start tweeting in this application. So hi Ignite, update. And now if I go to my timeline, I'll see sort of the timeline view of all tweets in this application. And remember, like I showed you the example of sets and sorted sets where I was able to do a timeline view, give me the last 5 or give me all the tweets. So you can use, it's using the same data structures, but it's now a PHP app talking to the Azure Redis Cache service. We also have this tutorial on how can you use an app which is using a Memcache protocol, and how can you use Redis Cache as a caching engine for it. So a perfect example is if any of you are doing building WordPress applications, you can follow this tutorial and use Redis Cache and then start scaling your WordPress applications or any app that uses the Memcache protocol as well. So it's another resource to sort of look out for. So let's go back to our portal, and I wanted to show you now sort of the diagnostic story behind cache. So when you create a cache, you'll see all this monitoring data for your cache. There's hits and misses, get set calls, the number of connections, total commands, CPU usage, network bandwidth, and you can expand any one of them and sort of get a graphical view. You can edit the chart And you can customize what's the time range you want to look at, like over a month, a custom date range. You can customize the perf counters that you want to add. If you add like expired keys, cache misses, used memory. And then once you add it, this data is going to get updated. So now I have used memory as well. I can also add alerts. So these are sort of monitoring alerts that I can add, saying if the cache read metric is greater than 5, then either send me an email or raise a notification in my app. And this is useful to understand if your cache is running hot and what can you do about it. And we'll talk about what can you do about it sort of in the FAQ section as well. And so for diagnostics, when you enable diagnostics, you'll be asked to provision a storage account as well. And a storage account is something that gets provisioned in your subscription. And the reason we've sort of made this change happened about, I think, in March, is if you provision a storage account, all the diagnostics data gets stored in a storage account that you own. And there's an SDK that you can use to extract these perf counters, and you can display them in your own dashboard, or you can have your own monitoring system around these perf counters. So perf counters are now accessible. Earlier on, these perf counters used to be stored in our infrastructure, and they were never exposed to the user outside the portal. But now you can have access to these perf counters outside the portal, and you can use them however you sort of seem fit. So that's a sort of a key message around the diagnostic story of the portal as well. And here's the sort of the RBAC support, where you can have users and you can define roles and you can define permissions on what operations can these users do in your application as well. All right. Any questions? Yes.
You mentioned that Redis on Azure is using a Windows port of the Linux.
Right.
So is it the same as the one that's maintained by the Open?
MS OpenTech? Yes. So the history behind is the Redis implementation is on Linux. There is an MS OpenTech port that they ported from Linux to Windows, and you can self-host Redis on your machines. And then Azure Redis offering is a fork of the Windows port, and that fork has add-ons that we've added in Azure. For example, the SSL support is only in the Azure fork of Redis. But yeah, it's the same engine that's there in the MS OpenTech port of Redis.
Is that available on GitHub too?
The source code is available on GitHub, yes. I saw another hand, yes.
What kind of security is like access security? Like which servers can access it? Is that done at the Azure level or at the Redis level?
So the security on Redis is you get a endpoint and you get a key that you can use to talk to. The endpoints are public, but the exchange is basically with the hostname and the key, and then SSL is the second level of protection that you have. Sort of to extrapolate on the point, so the question was, what level of security do you get? And so you get a hostname and a key, and then an SSL. Any data that you store in cache, you have to be cognizant of what data you're storing. You might want to consider at least like encrypting data if the data that you're storing in a cache is sensitive to your application. So that's purely an application-specific need. Yes? Is there a size limit on the value? No. Is there a size limit on the value? There's no size limit on the value. It has it'll impact what latencies do you get. So if you're dealing with large keys and large values, your latencies might vary, and you might have to adjust your app settings to handle that situation. And I'll talk about it in my FAQ section. Yes?
Is there any way to achieve some type of tenant isolation if you were having a multi-tenant app? You wanted to isolate each tenant within cache?
It is already isolated. So Redis is a single tenant service. All caches are isolated from each other.
I see. You just have it in cache each time.
Yes. So each cache, when you create a new cache, there's a new VM that gets provisioned for your cache. Yes?
The session and output providers that you mentioned, are they only available for Azure, or will they work for the on-premise?
So the question was, the session and output cache providers work for the Azure offering or any Redis server? They'll work for any Redis server. Yes?
We want to implement a client-side autocomplete feature. Would you recommend Redis cache? And if so, would it be possible to integrate it with a traffic manager component to get the closest geo?
So the question is, if I wanted to have an autocomplete on the client side, would you recommend Redis cache? And can you use it with traffic manager? So the first part is, if you're a client side, if you're talking about JavaScript code, then you normally would talk to a backend service, which is like Web API, and your Web API is then calling into the cache service, and then it's returning the result to you. So that's how you would implement autocomplete. Traffic manager, I'll have to understand that scenario a little bit more, so we should chat about it after we are done with the talk. Effectively, I mean, cache can coexist with the same region as your website, and so that's basically it. So cache doesn't have any specific requirements or tie-ins with traffic manager as such. Yes?
Some of the methods have async on them.
Right.
Are all methods async, or are there sync and async?
They're both. So the Stack Exchange support both sync and async. The answer is yes, and you can use either one in your applications. Right. So I'll jump into the FAQ section. Right. So the first question is, which Azure cache offering is right for me? Some of you might know that we've sort of had a history of offerings that we've done in Azure around cache. We love cache. But so far, it looks like Redis is very popular. And we recommend Redis for any new developments that you have. We also have Azure Managed Cache as a service. It's still supported, but we do strongly encourage folks who are building new applications to use Redis. There's also an in-roll cache. In-roll cache is a cache that you host yourself. It's not a service, so there's no SLA on that in-roll cache itself. So that's sort of the three caches that we have, and we recommend Redis for all new caching requirements. How to pick the cache SKU? That's, I think, the number one question that we've got. And the reason I sort of want to highlight this slide is because when you pick a cache SKU, for the most part, folks are interested in what's the cache size, and that's how they determine which cache I'm going to pick. Do I want a cache with 250 MB, or do I want a cache with 6 gigs, or do I want a cache with 53 gigs? That's fine, but you have to understand that along with the cache size, there's Redis server which is running. And so Redis is a single-threaded server. It queues in commands as they come. After a certain point, the number of commands might grow, and the Redis server might slow down. That can also happen because of network latencies between your client and the server. If your client can only push at the rate of X megabits per second, then after a certain point, if you have a million keys, or you're doing a million operations, or if you have large keys, you'll start to see high latencies and high timeouts in your client applications. And as you pick bigger cache sizes, apart from getting a higher cache size, you also get more bandwidth on the server side. And that's not something very obvious, so I just want to strongly enforce that point, that as you go up the cache size, you also get higher network bandwidth and higher CPU usage for your Redis service. And I'll show you a slide which talks to you about it. And make sure that your clients and caches are in the same region, otherwise you just lose the benefit of having a cache. How do the latencies and performance numbers look like for the cache offering? So for the 50th percentile, what we have seen is it takes under 3 milliseconds. For the 99th percentile, it takes under 10 milliseconds, and that's a consistent low latency that you should see in your applications. And if you're not seeing these, then there are some steps that you have to do to measure that latency and fine-tune your application. And the way we measured this was we used Redis Benchmark, which is a tool that you can download from Redis, and we just did pings. Both the client and the cache were in the same region, and we were running sort of a lightly loaded cache. So here's what the numbers look like. The bandwidth numbers are not guaranteed. There's no SLA. These bandwidth numbers are something that we got while doing load testing ourselves. Azure does not provide these bandwidth numbers for virtual machines as well. And so that's sort of a guideline on if you start to see high latencies and high timeouts, then maybe you're hitting bandwidth limits, and here's an approximation. So in terms of throughput, the third column, you can look at the number of get-set operations Redis can run. And if you're at a 53 gigs, it's like 153,000 get operations per second. And this is with the assumption that the key size is 1 KB. And so that's the Redis is like super fast in terms of the throughput that it offers. In terms of bandwidth, that's an approximation. This is meant to be a guideline for you to sort of understand that when you pick a cache SKU, you should consider the bandwidth numbers that you get from the cache SKU as well, because both you can get you can reach the network bandwidth limits both on the client and the server, and you'll see high latencies and high timeouts in your application. And you start seeing them, just move to a higher SKU. The last one is around the number of cores. Like effectively, you're provisioning VMs for you, and they're roughly mapped to like A0 to A7. So Redis is single-threaded, and if you're picking between C0 and C1, the CPU is shared between the Redis server and our infrastructure. And so the performance that you get from a Redis instance is not very high. As you start going up the scale, now the VMs have multiple cores. That means our infrastructure can run on a different core, and Redis server can get a full dedicated core to itself. So that's why it has the number 1. Yes?
So is there high availability?
High availability is offered on the standard SKU. So if you pick any cache size and you pick the standard SKU is when you get the high availability and the SLA of 99.9. So again, so if you're picking a cache SKU, pick up the cache size. Do you want high availability? If so, pick the standard SKU. Consider these network bandwidth numbers. Run your app, load test your app, see what the load is going to be on your cache. You might be hitting these network limits both on the client and the server as well. And if you're hitting on the server, then sort of move up. And then keep in mind that the Redis is a single-threaded server, and having a dedicated CPU for Redis is beneficial. Question, yes?
How do these numbers work with so these are the read operations, but you supposedly need to update cache and you need to populate cache. So if the data goes down, you need to like 53 gigs, you need to load it up. So what does it take to load it up for such,
So that's an how
does these numbers, do these numbers go with the write operations?
So these numbers will vary depending on your application workload, and these get operations per second will vary based on the operations that you are running. So if you are loading up a 53 gig cache with a data size which is, let's say, 1 meg, the number of operations per second that you will be doing is less. So what we recommend folks is use this as a very broad guideline and do load test your own application and your own workload, and then see what numbers you're getting in your application as well. All right. So why do I see high latencies in my application? The primary causes are either the cache or the client is not in the same region. You're hitting that network bandwidth both on the client and the server, because either the client is not able to send at the rate at the good rate, or the server is not able to receive at that rate. You're using Redis commands which take more time. So for example, if you run the keys operation, it's going to list out all the keys in your cache, and if you have 1 million keys, it's going to take a while for you to execute a command. And remember that Redis is single-threaded, and it processes each command one by one. So if you have a keys command and you have 3 gets after it, the 3 gets will never get executed until the keys command finishes. And so it will build up a queue. So those are operations that will take time and will increase the latency for your application as well. How do you scale Redis? So there are 2 ways to scaling Redis. You can scale up and you can scale out. Scale up is something that we are working on right now, and we should be able to offer it pretty soon, where you sort of go from a smaller instance of the cache to a larger instance of the cache, so you get more cache size, you get more bandwidth, and if you're on a shared CPU, you get a dedicated CPU for your Redis server. Scale out is sort of, you can do 2 types of sharding. You can do a client-side sharding or a server-side sharding. Microsoft has the patterns and practices team has published a white paper that I have a link to on how can you do client-side sharding. Like, very simplistic term. Maybe you say keys from A to Z go to cache 1, keys from M to Z goes to cache 2, and that's basically a poor man's client-side sharding. Server-side sharding is clustering, which is now offered in Redis, and we are working on offering it on the Azure as well. Do monitor sort of Redis operations in the portal. You can set eviction policies. So by default, Redis uses LRU, which is like least recently used, and you can configure which one of the policies you want to apply to your keys. Set alerts, monitor Redis using the Redis tools as well. So I'll show you how to run Redis CLI and Redis benchmark and what numbers you should care about. In particular, you should care about high fragmentation. So this is when your use memory RSS grows higher than use memory, then basically what it means is Redis has allocated much more memory than what the operating system has. So you'll start to see more paging. You'll start to see high latencies as a result of sort of high fragmentation. And the way you can do it is you can drop down to the console, and you can sort of run Redis CLI. Right. So Redis CLI is a tool that you can download. I have a link to it. And so now you can connect using the key, and you can run the info command, which basically puts out all the perf counters from the Redis server. So this is if something is not exposed in the portal, then you can use the Redis info command to see these perf counters. And then you can basically come and look at the used memory and the used memory RSS. And usually, if used memory RSS is slightly higher than used memory, then it's fine. But if it's like extremely high, so for example, it's like double or triple, then you have high fragmentation, and like the OS is going to page, and your latencies are going to go up. And so in that case, either you're hitting the cache size limits or the network bandwidth limits, so move up scale up your cache instance. You can also run Redis benchmark. So Redis benchmark is a tool that you can use to load test your Redis instance, and we recommend it to use it to see if there's a bottleneck in the client that you're using or on the server. So Redis benchmark will give you the true numbers of what the latencies are by directly talking to a Redis server without introducing a client layer like Stack Exchange Redis or any other client that you have. And you can do multiple things. You can just measure get, you can just measure sets, or you can do a random sampling, which will execute all commands in Redis. You can sample the data randomly as well. You can sample the key size randomly as well. So you can do lots of things. So you can run it. You would see that the latencies I'm getting is pretty high in terms of 63 milliseconds. And this is because my client is not in the same region as my cache. So I'm running my client locally on my laptop, where my cache is in North Central US. And that's why you see high latencies. I can go to a VM, which is in the same region, and I can run Redis benchmark, and the latencies number are going to be much lower now because at least I'm in the same region now. Maybe the VM is not as fast as it should be. So that's what happens when your cache and client are not in the same region. And that's how you can use tools like Redis CLI and Redis benchmark to get more perf counters from Redis. Client configuration. Right. So remember when I showed you in my demo on how do you connect to Stack Exchange? Stack Exchange also has these 3 values. The first one says abort on connect equals false. That means that if a connection fails, do not abort. Let Stack Exchange retry itself. I think it has good defaults of retrying logic. Do not introduce your own retrying logic as much as possible. And the next 2 are how many. Oops, sorry. So I was talking about a bot on connect fail equals false. So I think the default value is false, and this allows Stack Exchange to reconnect, to retry itself. The connect retry is how many times should I retry, and connect timeout is how long should I wait before I retry. And now, so depending on your load, you'll have to sort of fine-tune these values. For the most cases, the 80% case, the defaults are fine, but there's always the case of sort of fine-tuning these values as well. And you don't want to, the timeout value shouldn't be too small. Like, so for example, if you're dealing with large keys, which take about, let's say, 20 milliseconds for the operation to complete, your timeout cannot be 10 milliseconds because your app will never run. So depending on your workload, fine-tune these numbers, measure these numbers, and then set these numbers. Also, if you are using large keys and you have long-running commands, then you might want to think about using different instances of connection multiplexers in your app. So remember what I told you was earlier, we recommend use a single connection if you're going to have a stable load entire app. But let's say now you have an application and you're seeing that you have mainly two use cases of the cache. You have keys which are smaller and keys which are larger. So you can have two instances of connection multiplexer, one which can be used for keys which are smaller and they can have different timeout values, one which can be used for keys which are larger and they can have different timeout and connection retry values. So you can be intelligent about how do you use the client and how can you configure these timeout values based on the workload that you have in your app. So kind of sort of a best practice / guidance on that. Any questions? Yes. Is the question that when we have the master slave, is the slave kept in sync with the master? Yes. So when you sign up for the standard SKU, we provision two nodes, master and the slave. The slave is always kept in sync with the master asynchronously. And whenever there is a failover condition where the master goes down, like that could be because the network went down or Azure is patching the machine, then we'll switch to the slave and all the traffic will get routed to the slave. When the master comes up, at the next failover, we'll promote back to the master and we'll keep them in sync. Yes. Yeah. These are sort of cache patterns that you can have. You have a cache aside, which I showed you earlier. You have different retry logics that you can have. So you can have exponential backoff, or you can have backoff every 5 minutes. There's a link to it in my resources slide, which takes you to the Microsoft Patterns and Practices guide on these cache patterns as well. So I'm going to sort of talk to you about the upcoming roadmap that we have in terms of what features can you expect from Redis cache. So we're working on scale up and down. So you'll be able to scale up or down your cache instance. We're working on configuring Redis. So you can use a key space notification. So this is a feature where clients can be notified when keys are expired. So it's basically an event that gets raised, and you can handle that event on your client code and perform some operation in your client. We're going to offer persistence. We're going to offer Redis in all regions. So we're working on China and the government cloud. We are working on clustering. We are working on, I think this is further down in our roadmap is a geo-replication. So this is a scenario where now I have an app which is geo-replicated. My website is geo-replicated. Today I have to provision a cache in each region, but all the caches are not in sync. So if a region goes down, then I have to populate the cache myself by having a startup job and stuff. So this feature is, keep all the caches in sync. And then virtual network. So this is around running a cache inside a virtual network and only allowing access to the cache, through certain IPs or something similar to it. So that's sort of the virtual network offering that will come in cache. So these are all the resources that I have. If you have access to the deck, you can click all these resources. There's a pricing link. The price for cache is not sort of per transaction. It's a fixed cost that you pay per month. There's the documentation page, which has all the samples I've showed you. It has all my samples are on GitHub, and the documentation has linked to it. If you have any feature requests for cache, then go to our user voice. There's the Microsoft patterns and practices that they just published on GitHub on caching in general, retry policies, how to build scalable applications in Azure. There's a blog post which talks to you about in great detail that if you start seeing timeout exceptions, what does it mean? There's the link to the Memcache protocol shim, which is the walkthrough on how we can use the Redis cache to shim the Memcache protocol. So that's all I have for today. If you have any questions, we still have about 4 minutes which are left. If you want to come after the talk, then I'll be over here. Thank you so much for hanging around the talk, and hope you guys have all this information cached. Thank you.